Hi there. Well, we're going to look at 3.7 and 3.8, which will finish up this chapter. And excuse me, what we'll be looking at first off is finding the reciprocal. And then we'll look at some applications of using the reciprocal. So on this first one, 10/13, they want you to find the reciprocal of 10/13. Well, to find that, oops, didn't come out very clear. Oops. There we go. You just flip it over. So the reciprocal of 10/13 is 13/10. On number 6, the reciprocal of a -7/3 is a -3/7. Notice that if I start with a positive, the reciprocal is positive. If I start with a negative, the reciprocal is negative. So the reciprocal does not mean opposite. So don't get that confused. So the reciprocal, the sign stays the same here. Here, the sign, if it's negative, its reciprocal is negative. So don't switch the signs. Also notice that if you were to multiply a number or a fraction times its reciprocal, if you were to multiply these two together, the 13s cancel. 13 goes into 13 once, so you end up with a 1 and a 1. 10 goes into 10. So when you multiply reciprocals, you always end up with the number 1. So so that way you know that it's right. Here, a negative times a negative is a positive. So you would also end up with a positive 1. The 3's cancel and the 7's cancel. Okay, so what happens if you're given a whole number, like here on number 7, you have the number 5. To find its reciprocal, you just take 5 over 1. Put your whole numbers over 1. It could be a variable x or y, but you put them over 1, and then you find the reciprocal of 1/5. Just don't make this harder than it is. Let's look at number 8. The reciprocal of s over t is t over s. All right. So knowing this, you can get quite a few of the problems done on this assignment. I think there's like 5 or 6 of these. Here, the reciprocal of a -7 over x, a -7x over 5y is a -5y over 7x. It doesn't really matter where you put that negative. I'm just keeping the negative in the numerator, but it wouldn't matter. In my math, whether or not you wanted to put it in the middle here with the fraction bar, or keep it with if you're more comfortable keeping it here with the 7x, you can do that, as long as you have the negative somewhere. All right. Let's look at number 10, a -1 over 4r. Well, the reciprocal of that will be negative, because we never change the sign. When we're finding reciprocal, we never change the sign. It would be 4r over 1. But normally when we have that 1, like we did here, we just write this as -4r. It would be the reciprocal. It's not that this is wrong. This is just more standard in order to write as a -4r. All right. So that's reciprocal. Now we're going to use the reciprocal when we start dividing fractions. That's one of the applications. There's other ones, but this is one of the applications. We're also going to use it in solving. We're going to use it when we find perpendicular lines, when we find equations of perpendicular lines. The reciprocal will come back, and you'll need to remember that. Okay, let's look at number 11 here. We have 3/4 divided by 4/9. In order to find the quotient here, we will take 3/4 times 9 over 4. So what we say, this is a copy dot flip. All right, copy dot flip. So you do this before you start to reduce. All right, you need to do the copy dot flip. We say that we usually take the multiplicative inverse and multiply, or the reciprocal and multiply. But an easy way to remember this is a copy dot flip. So rather than say reciprocal, it's flip, which means the same thing. Reciprocal is just flipping. So now once you've done, when you're dividing fractions, we did the copy dot flip. Now you reduce if possible. And then once you've reduced, you multiply straight across. So division is just one extra step in multiplication. And this extra step has to be done before you start to reduce. So you do need to do this step first, this copy dot flip. So now if you look here, neither one of these is reducible with either one of the 4s. Nothing goes into one of these numbers that would also go into one of these. So then you just multiply straight across. So you end up with 27 over 16. Okay. Now again, if you reduce here, you won't have to reduce here. If you reduce before you multiply, you will not have to reduce after you multiply, which is kind of nice. Okay, let's look at this next one, another one here. We've got 7/8. So we copy dot, we have the reciprocal or flip. All right. So again, we have copy dot flip, where the flip is the reciprocal. So this is one of the applications of the reciprocal. You always do this step first when you're dividing fractions. Then you reduce if possible. Well, we can reduce because we have here in the numerator, 7 goes into here and 7 goes into here. 7 goes into there once, 7 goes into there once. So I was able to reduce those. The 11 and the 8, I can't reduce anything there. So once you've reduced, you multiply straight across. So 1 times 11 is 11. 8 times 1 is 8. And there's your answer. Okay. All right, let's do another one. Again, this is a division of 2 fractions. So we'll do our copy dot flip, where the flip is actually the reciprocal. But we'll copy the first one always. Dot flip. So this flip is the reciprocal. And you reduce if possible, and then you multiply. I do know, looking at this, that my answer is going to be negative. And the reason it's going to be negative is because in division and multiplication, if you only have one negative, one is odd, your answer is negative. So we know that our answer will be negative. But let's go ahead and try to reduce. I've got these 2 numbers and these 2 numbers here. Looking at the 10 and the 5, I know that 5 goes into both of those numbers. So I'm going to divide this by 5 and get 1, and this by 5 and get 2. Now it looks like that's all the reducing I'm going to be able to do, because there's not a number that goes into 2s, but would also go into a 13. So once we've done that, we're going to multiply straight across. We have a 2 times a 2. We do need to have a negative somewhere. 2 times 2 is 4. 13 times 1 is 13. So it's just like the multiplication that we did in the last section. It's just that now you've got a copy dot flip. All right, let's see what we've got on the other side here. More practice. Well, let's go ahead and we'll look at number 15 here. All right, I don't know if we need to do all of these. We'll just kind of pick and choose. I've got a whole number, and I'm dividing by a fraction on number 15. I have this negative 36. So if your first number, I guess it's not necessarily a whole number, would be called an integer. Whole numbers are positive. So I have this integer. And if you have just an integer, go ahead and put it over 1. It makes the multiplication a lot easier. So when I do this one right here, I'll have a negative 36 over 1. All right, that would be my copy. You always copy the first one. Copy dot, which means multiply. And then we have the flip, 5/12, which is our reciprocal. So we have our copy dot flip. We've made it into a multiplication problem. So we changed this to multiplication, and we took the reciprocal of the 12/5 and got 5/12. So now again, I know that my answer will be negative, but I want to reduce before I multiply. And I do know that 12 goes into 12 once, and 12 also goes into 36. And what you can do is, if you didn't know that 12 went into 36, you can just you can divide them by 2, and you can divide them by 2 again, and you can just kind of keep reducing them with just a single 2, and then pretty soon you'll say, oh, 3 goes into it. So, but knowing that 12 goes into here once is a little bit faster, and 12 goes into here 3 times. It makes it a little bit quicker. So now when I multiply straight across, I come up with, I know my answer is negative. 3 times 5 is 15. 1 times 1 is 1. When I have the 1 in the denominator, we'll just drop it. So your answer is a negative 15. All righty. Well, that's what happens if you have an integer for your very first number. What happens if the integer is here instead? Well, what I'll do is I'm not going to do my copy dot flip yet. Oh, got the 2 divided by, put your integer here over 1. And now you can do the copy dot flip. So this one is 21 over 23. Is it staying focused? Oh, yes. Times 1/7. So we have a copy dot flip. It just takes some practice. You guys will, it won't be too bad. So again, I'm going to reduce before I multiply, and anything here with anything here. And it looks like I got the 7 and the 21 will reduce, because I know that 7 goes into there once, 7 goes into there 3 times as I reduce. 3 and the 23 do not reduce, because 3 will not go into here, because the sum of these two is 5 and 3 doesn't go into 5. So we multiply straight across. 3 times 1 is 3. 23 times 1 is 23. So there's your 3 over 23 is your answer. So again, let's look at 17, and then I want to look at some with some variables in them. The variables really don't add much difficulty. Looking at number 17, I have 2 fractions. I don't need to put anything over a 1. I don't have an integer. But here, what we'll do is we'll take copy, dot, and then we'll flip. So we take and copy the first one, change the division to multiplication, and then we take the reciprocal of the next one. And it's always the reciprocal of this one that follows the division sign. We don't take the reciprocal of the one in front of the division sign. It's a copy dot flip. Okay, looking here to reduce this, 3 goes once. 8 goes into here once, 8 goes into here once. So it looks like when I multiply, I get 1 times 1, 1 times 1, which is 1. So I was multiplying a number times its reciprocal. When I take a number and multiply it times our reciprocal, you get 1, which is what we got. So that's awesome. Okay, well, let's put in a few variables. Let's look at number 20. Okay, let's skip down to number 20 here and see what we can do. We have a y in here. So I'm going to go ahead and put the 28y over a 1. Make it a fraction. So I have 28y over 1. I'm going to keep the division sign. I'm not going to do anything yet. I just put that 28 over 1. Now I'll do a copy dot flip. So we have a copy, multiplication, flip. All righty. So now we'll reduce anything here with anything here. And you can reduce the 2 and the 28. All right, there's going to come a time, maybe this, I don't know if we'll get to it this semester, but those of you that take 930, we're going to be adding some plus, signs here and making them polynomials, but as long as it's all multiplication, they're next to each other, you can separate the 28 and reduce it separately from the y, which we're going to do because I know that 2 goes into 2 and I know that 2 goes into 28. So it can be separated and dealt separately than the 28, and the y can be dealt separately. So 2 goes into 2 once, 2 goes into 28 14 times. Hey, it looks like all the reducing we need to do. So we're going to multiply straight across. We'll take 3 times 14. So we'll do the number first. Okay, it's called the coefficient. When you put it in front of a variable, we'll take 14 times 3. That's going to give us 42y. All right. Now that would be the numerator. The denominator would be 1 times 1, but we don't need to put that in. So 42y. So really, when you have variables, it's pretty much done. They just kind of go along when you multiply. All right, let's look at number 22. Okay, now number 22 is actually called a complex fraction. It's a fraction within a fraction. Well, what we're going to do is we're going to rewrite this fraction. So this bar right here, these fraction bars actually mean divide. So I'm taking 16 divided by 27, and then that answer divided by whatever you would get here, 48 divided by 9. So I'm going to rewrite this because I know that this bar here means divide. So I'm going to take the numerator here, this top fraction. That's a 6, sorry. And then I'm going to replace this fraction bar with divide. So when you're given a complex fraction, rewrite it like this. All right, take this bar here. You write this first, whatever it is, and this could even be just an integer. And if it's just an integer, it will look like something like maybe, oops, I'm not sure why this keeps going out of focus, but just keep refocusing. If it was an integer here, you would write, so this could actually be a complex fraction. Let me write this as a complex fraction. Okay, these two statements mean the same thing. So you take this top number divided by the bottom number, or the fraction, all right? So you just take this divided by this. Or if you have two fractions, which is what we have here, you take the top fraction, replace this bar with a division, then divided by the bottom fraction, and rewrite it like this. Now we have a copy dot flip. And then you're just going to need to reduce that. And looking at that, I know that we have a negative times a negative, which is a positive. So I know that my answer will be a positive, and we'll reduce it. We can start with the 16s. Let's see. 16 goes into here once. 16 goes into here 3 times. Wow. That's pretty nice. And then 9, you can either reduce the 9 with the 3, or you could reduce the 9 with the 27. It doesn't matter, because anything here with anything in the denominator. Let's do the 9 and the 27. 9 goes into there once, 9 goes into there 3 times. I can't reduce these because they're straight across. You can only go top to bottom. So that's all the reducing I can do. So we come up with, we know it's positive because we have 2 negatives, which is even. So we know it'll be a positive. So when you have an even number in multiplication or division, an even number of negatives will always be positive. 1 times 1 is 1. 3 times 3 is 9. So the only thing different is rewriting it like that. All right, taking that top fraction divided by that bottom fraction. And let's look at this one again that we had. This one here, let me get a piece of paper to cover up the other information to make it a little bit, so there's not quite so many problems to look at. Here, this one could have been written like this. So we write this first, this top number. This is a division, and then we write the bottom. And then from there, it's just a copy dot flip. All right, so you just rewrite it first. Okay. All right, that's it for section 3.7. So that's great. We're now going to look at section 3.8. 3.8 is we will be using the reciprocal to solve equations. So we use the reciprocal in division of fractions. That was that flip. And now we're going to look at all right, so one of the applications, like I was just saying, of the reciprocal with division, and you can also use the reciprocal to solve a problem like this. Now, we'll also be looking at some different methods of solving this type of an equation. But if you're given just a fraction in front of a variable, and that's the only thing you have to get rid of to solve, to get the x by itself, you can use the reciprocal of the 5/6, multiply that to both sides. Because remember, we ultimately want a 1 in front of the x. And if you take a fraction times its reciprocal, you'll get the number 1. So if you have a fraction multiplied to a variable, and that's the only thing you need to get rid of, and then the variable is solved for, there's a 1 in front of it, then this is probably the easiest method. So what I will do here, I'm going to copy this because that 5 there is in the way. Now remember, whatever you do to one side of the equation, you're going to need to do to the other side of the equation. And if it helps, you can always draw a line through there so that you know whatever you do to one side, you'll need to do to the other side. So to get rid of the 5/6, I'm going to multiply by 6/5. I'm going to multiply by the reciprocal of the fraction in front of the variable. The 5's cancel, the 6 cancel, and you're left with just a 1x, or just x. Well, now you still have to deal with the other side, because whatever you do to one side of the equal, you need to do to the other side. Well, in order to multiply those, I'm going to put the 20 over 1, and then I'm going to reduce and then multiply across. Well, 5 goes into there once, 5 goes into there 4 times. So I've reduced it, and then I multiply across. 4 times 6 is 24 over 1, and you don't have to put that over 1, and I'm really sorry that that went out of focus. So again, I reduced the 5 and the 20. So 5 went into there once, 5 went into there 4, and then I multiply straight across once I'm done reducing. So 4 times 6 is 24. So you can check this. You can put 24 back up into here. 5/6 times 24 is 20. All right. Okay. Now, again, notice that when I multiplied by the reciprocal, I didn't change the sign. The sign stayed the same. So again, you're multiplying by the reciprocal of that number in front. Well, let's go ahead and look at number 6. I have a -2, I have a -2/3 x. To get rid of that -2/3, so I have the number 1 in front of the x only, get the x all by itself, that's our goal. To get rid of this, I will multiply by the reciprocal. So right now I have a -2/3 x equals 12. All right. Now, to get rid of that -2/3, I will multiply by a -3/2. So I multiply by the reciprocal, and remember the reciprocal, you keep the same sign, you keep the negative. So then whatever you do to one side, you must do to the other side. So we end up with this right here. So again, whatever you do here, you do here. So these cancel, these cancel. A negative times a negative is a positive. So we know we end up with just X. All right. Then on the other side, okay, because we got rid of our number that was in front of the X, we were able to get rid of that. So here I'm going to put 12 over 1. And I'm going to reduce it. So 2 goes into here once, 2 goes into here 6 times. And so then you multiply across. 6 times a negative 3 is a negative 18 over 1, which is just a negative 18. So if you were to put the negative 18 into here, negative 2/3 times a negative 18, a negative times a negative will give you a positive 12 when you multiply those together. All right, let's look at another one. It's a little different now. Here I have a whole number, 10 times a, and then over here is a fraction. Well, you could divide by 10 to get rid of that 10 here. So there's a couple of ways to do this. So if we were to divide by 10, I have A equals, because the 10s cancel, 25 eighths divided by 10. All right. Well, in order to finish this, okay, so again, this was 10 times A. So I divided by 10 both sides to get rid of that 10 in front. This leaves me with 28. I'm going to do a copy dot. This is 10 over 1, copy dot flip. Okay. So I put the 10 over 1, okay, and then I did a copy dot flip. So this one, because it was just an integer times A, I divided to get rid of that. Okay, and then I just put a divide by 10 over here. So then we end up with a copy dot flip. I'm going to reduce this because 2 goes into here 5 times. 2 goes into here 14 times. But I can still reduce. 8. Oh, where did I get? I'm sorry. This was supposed to be a 25. So I'm going to have to start over again here real quick. Sorry about that. I have no idea where I got the 28. That's okay. It's not that big of a deal. So again, I'll do a copy 25 times 25 eighths times 1 over 10. It makes it a little bit easier to reduce. Now, 5 goes into there twice. 5 goes into there 5 times. Now that's all the reducing I can do. So I multiply straight across. So I end up with 5 over 16. If you were to put this in for A, because our original was this, if you were to put your answer in, when you take 10 times the A, this number, you should get 25 eighths. Let's see. A is 5/16. We're checking our answer here. Well, to take 10 times our A, I'm going to put 10 over 1 times 5/16. 2 goes into there 8 times. 2 goes into there 5 times. When I multiply across, I get 25/8, which is what I wanted, 25/8. So you can check by putting your answer in and then multiplying. So again, let's look at that one more time and we'll do another one. Just that when you have a 10 times A, you divide by 10, but because it's a fraction over here, I put my divide by 10 out here. All right. And then I did my copy dot flip. So then I had this, I put my 10 over 1, and then I did a copy dot flip when I did this right here. Okay. All right, let's look at number 8, which is very similar to number 7 that we just did. Okay, so I have 4/9. I'm going to copy it out so we have a little bit more room, equals a -6y. What I need to do is I need to divide both sides by a -6. So sometimes I've noticed that some students want to divide by a +6. They always want to divide by the opposite, but the only time we have opposites is when we're adding or subtracting. That's when you have the opposite. So I am going to divide both sides by a -6. So I'm going to take 4/9 divided by a -6. Or here's another, well, you could multiply by a -1/6 both sides. You could multiply by a -1/6 just because you have this fraction. And some of you may have learned that as well. But I think what we'll do is we'll take and we'll divide by a -6. I don't have any room, so I'll just divide by a -6. So I'm dividing both sides by a -6 here. Now, what I did on this one over here is I had room to write divide by 10. I just didn't put over 10. I didn't make my complex fraction. I just put divide by 10, but I didn't have the room over here, so I put it underneath because the equal sign was too close. So this is a complex fraction, so I have 4/9 divided by a -6. These two statements mean the same thing. So then it's a copy dot flip. When we do the copy dot flip, we have to remember that the -6 is over 1. So we have a copy dot flip. And we'll reduce it. 2 goes into here twice. 2 goes into here 3 times. And that's all the reducing we can do. So we'll multiply straight across. 2 times 1 is 2. 9 times 3 is 27. And I have one negative, so the negative stays. And there's your answer, -2/7. So again, I'm just dividing by a -6, both sides. All right. All right, let's do some more here. Let's look at number 9. I don't have a whole number like I did on 7 and 8. And if 7 and 8 still are confusing to you, please let me know and I can explain it to you again. All right, let's look at 9 and 10. And then we're going to look at some story problems or some word problems. I have a fraction in front. It's not a whole number like we did on 7 and 8, but here to get rid of this, now again, I keep the sign, for some reason it comes out of focus. Here I will multiply by a negative, okay, you keep the sign, a -9/8. So I have a -8/9 x. So I will multiply by a -9/8. So I'm multiplying by the reciprocal, and the reciprocals keep the same sign. So what happens on the left is they cancel. And negative times a negative is a positive x. Over here, I'm going to see what I can do to reduce before I multiply straight across. 9 goes into here once, 9 goes into here 3 times. That helps. 4 goes into here once, 4 goes into here twice. Okay, so my answer when I multiply across, a negative times a negative is a positive. 2 negatives even, so you have a positive answer. So we have 1 times 1 is 1. 3 times 2 is 6. 1/6. So let's check it. I have a negative 8/9 times the x is 1/6. Do you get negative 4/27? Do you get a negative 4/27 when you put your 1/6 back in? Let's check it and see. Well, let's reduce it. Let's see, 2 goes into here 4 times, 2 goes into here 3 times. Looks like that's all the reducing we can do. A negative times a positive, 1 negative is odd, so it's negative. 4 times 1 is 4, 9 times 3 is 27. So it does check when you put the 1/6 back in. All right, let's do one more. Here, I have a negative 3/4 a, which I have to get rid of. I need to have the a by itself, 9/16. To get rid of the negative 3/4, I'll multiply by the reciprocal. And the reciprocal, you don't change the sign. It still will be negative 4/3. So when you multiply or divide to get rid of a number, the sign stays whatever that number is that you're getting rid of. If it was a negative, if it was a positive, we multiply by the positive reciprocal. If it's negative, we multiply by the negative. So we'll do the same thing to the other side of our equation. Okay, cancel, 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 cancel. Negative times a negative is a positive. So we have 2 and 2 is even. Over here, I'm going to reduce as much as I can. 4 goes into here once, 4 goes into here 4 times. 3 goes into here once, 3 goes into here 3 times. So again, I'm just reducing. And I'm going to multiply straight across. I have 1 negative, which is odd, so my answer will be negative. 3 times 1 is 3. 4 times 1 is 4. So if we were to put that back into our original, we were to put this back into the a here, we would have a negative 3/4 times our a, which is a negative 3/4. Do you get a positive 9/16? Negative times a negative is a positive, and you multiply straight across because you can't reduce. So you do get 9/16, so it checks. All right, so I hope that helps on how to get rid of a fraction, or if you're dealing with fractions in your equation, because sometimes you're not necessarily trying to get rid of a fraction, you're trying to get rid of this integer, but you can treat it like divided by 10. All right. Or just like what we did with the with this one right here, we divided by a -6. And then I just rewrote it. Divided by a -6. Rewrote it like that. Okay. All right. But this is how you deal with the fractions, especially, this is useful, multiply by the reciprocal. But again, here I divided by a negative because I had to get rid of that -2. A negative over a negative is a positive. If it's a positive, you divide by a positive. Okay. If it's a negative, you multiply by a negative reciprocal. It stays the same. Here stays the same, -4/3. Okay, great. Now, I'm going to turn this over, and I think we're going to do story problems. Well, There's a couple more here, you know, that if you wanted to, well, here, this one, there's no fractions involved in this one. So it's kind of a nice review. It's a good review. Let's look. On this one, to get rid of the -4, if you'll notice here, this thing is going out of focus. All right, if you'll notice here, there's no fractions involved here. And so I wouldn't be dealing with reciprocal. All I would do would be, I would just divide by a -4, and I get x equals, and then I would reduce this fraction. That's all, because that would be to me, that would be the easiest. So you end up with 2 goes into 14, 7, 2 goes into 2 twice, and you do have that negative, because when you're dividing, you keep the sign. You don't make it the opposite until you're adding or subtracting. Then you add the opposite. So I do need to have a negative somewhere. It doesn't matter where. You can put it with the 7, with the 2, it doesn't matter. Just have one there. All right. So that was kind of a nice review of what happens if we're not dealing with them. With the fractions here, I would multiply by a -35 over 18 and multiply by a -35 over 18 and reduce it, so that those all cancel. And again, I would keep the negative, multiply by a negative. All right, and you can just reduce those and multiply through. But I wanted to look at a few story problems and then finish up with this section and be done with this video here. All right, so you're going to kind of need to reason through some of these, and you can make an equation if you need to, and we'll go through how to make an equation. You may not need to. You may know that you need to divide, or you may be able to figure out you need to add or subtract or multiply. But in case you can't, then we'll try to come up with an equation, and then you can solve it. All right, in a bag of candy corn, one piece weighs 2/33 of an ounce. One piece does. Approximately how many pieces of candy corn would it take to make a 10-ounce bag? All right, so what you've got here is you would take the number of, or the weight, well, no, it's right, the number of pieces. I have no idea why I just switched those. The number of pieces of candy times the weight of each piece will give you the total. That's kind of the idea here. The number of pieces of candy times the weight of each piece would equal the total weight. Well, we don't know the number of pieces. They want to know approximately how many pieces. So this is kind of what we're looking for, the number of pieces. We're given the weight of each piece, and we know what the total bag needs to weigh. And one thing that they're not going to do, but you should get into the habit of checking, is to make sure that your units match. You know, if you're in 1500, you may have to be able to convert from feet to inches and or inches to yards or whatever, but make sure that your units match, which they will for the most part here. They're not interested in converting as they are, do you multiply or divide? Well, the number of pieces we don't know, so we're going to call it n, times the weight of each piece is 2/33 of an ounce, and that is going to equal the total weight of the bag, which is 10. So to find the number of pieces given the weight, you're going to divide to find the number of pieces. So you want the n by itself. So what we're going to do to get rid of this right here, rather than, I guess, divide by 2/33, we're going to multiply both sides by 33/2. And that leaves us with n equals, all right? So we needed to get rid of the 2/33. So we're taking 10 times 33/2. Now, some of you may have, without looking at the equation, said, okay, I know I need to take 10 and divide it by the weight of each one to figure out, oh, how many total pieces I needed. Some of you may have started here with a division, but if you had the equation to solve it, it's the same thing because this is a copy dot flip. This is a copy dot flip to answer this. So you're going to end up with this right here. So you end up in the same spot. All right. So now I'm going to take 10 over 1 times 33 over 2. 1, 5. So then you multiply across and you're going to come up with 165 pieces of candy is what you're going to need. Just is totally irritating. So again, here, whether or not you said, well, I need to take this and divide it by this to see how many pieces I've got. So if you started here, it's a copy dot flip. If you took this equation idea and solve the equation, you're multiplying by the reciprocal, okay, which is the same as the copy dot flip. And then you reduce and multiply. Okay, all right. Let's look at another one. All right, a log that is 35/72 yards long needs to be cut into 10 equal pieces for a woodcraft project. How long will each piece be? Well, you're going to take this and you're going to divide it. There's your key. You're going to divide it into 10 equal pieces. So you'll be taking 35 divided into 10 equal pieces. To me, this one's a little easier than finding an equation. It's just to reason through it. So this is a copy dot flip. So we will have 35 over 72 times, this is over 1/10. I would definitely reduce here. 5 goes into here twice. 5 goes into here 7. So it looks like each piece is going to be 7 over 144 yards each. Wow. I better not put that in case you guys think it's a subtraction. But that would be the number. That's how long each one would be in yards. And obviously, those of you going into construction or whatever, you would probably multiply that by 36 to change it into inches. So, all right. But I would just divide. You're dividing it into 10 equal pieces. Okay, let's look at one more. This one might be kind of, I don't know, maybe this one's kind of tough. We'll see. I'm going to use an equation on this one right here. A bottle of juice held 30 ounces when it was 5/16 full. How many ounces would a full bottle contain? The equation here means that if I take 5/16 times the total amount when it was full, I get 30 ounces. So 5/16 of the total was 30 ounces. So I was given the part here. I wasn't given the total, but 5/16 of the total was 30 ounces. So that would be the equation I would use to solve this. And in order to find the total amount here, because since I only had 5/16 of the total was 30 ounces, I would multiply by the reciprocal to find the total. So I would multiply by 16/5. So T is going to be equal to the total. T stands for the total, or what it's like when it's full. Let's go 30 over 1 times 16 over 5. 5 goes into their ones, 5 goes into their 6. So that comes out to be 96. 96 ounces. If you take 96 times 5/16, you're going to get 30. All right. Now, you can kind of reason through that. You can ask yourself, did I do this right? Because you expect it to be more than 30. And so if you were to multiply those two accidentally, let's say you multiplied those because you weren't sure what to do, you can always ask yourself, okay, does that make sense? Because if you multiply these, you're going to end up with less than 30. But you know that you want, how much was it when it was full? So you know you're going to need more than 30. So if you take 30 divided by this, you're going to come up with the 96. All right, well, that's all for this video. This will get you through 3.7 and 3.8. And then I'll do another one, I believe. No, I think that's it for the chapter. That's awesome. And then I'll do chapter 4. Okay, well, great. Have a great day, and let me know if you need any help. Bye-bye.